pod. Let me just check the audio, and we're talking a bit about general anatomy stuff too. We should be live, but yeah, we're live. Let me just check the audio as usual, and we'll be together in a few seconds.
Sounds good. It's always a good idea to confirm the audio. Once you're set, you can jump right into hematopoiesis and cover those general anatomy topics. Enjoy!
Excuse me if there's noise, guys. It's from outside. It's a bit hard for me to do something about it, but yeah, we left with hematopoietic stem cells ChatGPT. If we could kind of run through that for a sec.
Sure. Hematopoietic stem cells are the body's blood cell producers. They can differentiate into various types of blood cells, like red blood cells, white blood cells, and platelets. They're crucial for maintaining a healthy blood system. Anything specific you'd like to focus on?
Yeah, I was just wondering why the myeloid ones have monocytes, macrophages, neutrophils, basophils, eosinophils, erythrocytes, megakaryocytes, platelets.
Exactly. Myeloid stem cells give rise to a diverse group. Monocytes that become macrophages, plus neutrophils, basophils, eosinophils, red blood cells, and megakaryocytes that produce platelets.
Yeah.
It all starts from that.
And I'm just worried, I'm just curious to understand why.
It's all about specialization. Each of those cells has a unique role. Monocytes and macrophages handle infections. Neutrophils are frontline defenders, and red blood cells carry oxygen. The body's efficiency depends on having these specialized cells.
I don't understand how we categorize them to myeloid and lymphoid. I know it's because it's the progenitor, but why?
The distinction comes from their developmental pathways. Myeloid cells arise from the common myeloid progenitor, leading to granulocytes, monocytes, red blood cells, and platelets. Lymphoid cells come from a different progenitor, giving rise to B cells, T cells.
Yeah, we don't... Guys, I want to go through this, but to be honest, I only have limited amount of time today, so it's going to be a bit hard. Can we talk a bit megakaryocytes? So they're in the bone marrow, and are they... can they cause some kind of problems if we have too little or too many of them?
Absolutely. Megakaryocytes produce platelets, which are essential for blood clotting. If you have too few megakaryocytes, you might end up with a low platelet count, increasing bleeding risk. Too many could lead to conditions like thrombocytosis, raising clotting risks.
What is thrombocytosis?
Thrombocytosis is a condition where you have an abnormally high platelet count. This can increase the risk of blood clots, potentially leading to complications like stroke or heart attack. It's often detected through routine blood tests.
So abnormally low platelet count?
That's called thrombocytopenia. It can lead to excessive bleeding or bruising because your blood doesn't clot properly. Causes range from certain medications to bone marrow disorders.
So what's the difference between a thrombocytosis and thrombocytopenia?
The main difference is platelet count. Thrombocytosis means too many platelets, increasing clot risk. Thrombocytopenia means too few, raising bleeding risk. Both can have serious...
And when it comes to platelet activation then, what goes on with the respiratory rate?
Platelet activation triggers a cascade of reactions. They change shape, release granules, and become sticky to form clots. Respiratory rate doesn't directly affect platelet activation, but systemic issues like hypoxia might influence clotting.
It won't increase the rate?
In some cases, yes. If the body needs more oxygen due to blood loss, respiratory rate can increase to compensate. This doesn't directly activate platelets, but it's part of the body's overall response.
Mm-hmm. And in activation stage, do we have exocytosis of dense granules? And if yes, why?
Yes, we do. Dense granule exocytosis releases AEP, calcium, and serotonin, which amplify platelet activation and recruit more platelets to the clotting site. This helps stabilize and grow the clot.
Okay, can we talk about prasugrel?
Sure. Prasugrel is an antiplatelet medication used by inhibiting platelet activation, reducing the risk of heart attacks or strokes, especially in patients with acute coronary syndrome.
Interesting.
Glad that.
So, what about in aggregation? Prasugrel blocks it.
Exactly. Prasugrel blocks ADP receptors on platelets, which prevents them from aggregating. This reduces the likelihood of clot formation, helping keep blood vessels open.
Interesting. So in activation, we have extracellular ADP, which activates the P2Y receptor. What's going on there?
Extracellular ADP binds to P2Y receptors on platelets, amplifying their activation. This promotes further platelet recruitment and aggregation, crucial for forming a stable clot.
Interesting.
Glad you found it interesting. Anything else you want to dive into?
Yeah, I'm very tired, but I don't know. I should have time managed back there, I guess. Can we talk a bit about the clotting factors? So, for instance, we have factor XA and X.
Sure. Factor XA is a crucial enzyme in the clotting cascade. It converts prothrombin to thrombin, which then helps form fibrin, the protein that stabilizes clots. Factor X is its inactive precursor.
Nice.
Glad you liked it.
I'm sorry, guys, that we're not going into detail about all of this, because it's really interesting and it's a shame not to go into detail. Perhaps I can do another episode of this in the future. Can we talk a bit about factor 5 and 8 now?
Absolutely. Factor 5 and 8 are cofactors in the clotting cascade. Factor 5 works with 10A to convert prothrombin to thrombin, while factor 8 is crucial for forming the 10A's complex, which amplifies the cascade. Both are essential for effective clotting.
Interesting. And
Yeah, it really is. The clotting cascade is a fascinating system.
so what's the difference, sorry, a bit irrelevant, what's the difference between plasma and serum?
No worries. The difference is that plasma is the liquid part of blood, including clotting factors. Sera is what remains after the blood clots, so it doesn't have those clotting factors.
And the difference between thrombosis and embolism?
Exactly. Both can be serious, depending on where they occur.
What's the difference between thrombosis and embolism?
Thrombosis is when a clot forms in a vessel, blocking blood flow.
Whereas embolism?
Embolism happens when a clot, air bubble, or other debris travels through the bloodstream and lodges in a vessel, obstructing blood flow elsewhere.
So a thrombosis can become embolism?
Exactly. If a thrombus dislodges and travels, it becomes an embolus, potentially causing an embolism.
Okay. So we said fibrinogen becomes to fibrin through thrombin, and then what's going on? We have fibrin becoming cross-linked. We ask you again. So we have fibrin becoming to cross-linked fibrin, and which factor helps, and does calcium help?
When fibrin is formed, factor 13, also known as fibrin stabilizing factor, helps cross-link the fibrin strands to stabilize the clot. Calcium is also essential because it acts as a cofactor for several steps in the coagulation cascade, including the activation of factor 13.
Let's talk a bit about the intrinsic and the extrinsic pathway.
Sure. The intrinsic and extrinsic pathways are two routes that lead to blood clot formation. The extrinsic pathway kicks off when tissue factor is released after an injury, which then activates factor 7. The intrinsic pathway is triggered by damage inside the blood vessel, activating factors like 12, 11, 9, and 8. Both pathways converge at factor 10, leading to the common pathway where fibrin forms the clot.
Yeah, extrinsic is 3 and 7, right?
Exactly. Factor 7 plays a crucial role in the extrinsic pathway by binding to tissue factor. This complex then activates factor 10, which propels the cascade forward, ultimately leading to clot formation.
What about factor 13 when it comes to the intrinsic?
Factor 13 isn't specific to either pathway. Once thrombin is generated in the common pathway, it activates factor 13.
So in the intrinsic pathway we have sorry, I'm confused with extrinsic and intrinsic XAs, 10As. Can we talk about that too? It's been embarrassed, the ChatGPT. Okay. Can we talk about the intrinsic and extrinsic 10As?
Sure. Intrinsic and extrinsic tenase complexes are crucial in the blood coagulation process. The intrinsic tenase complex involves factors 8A and 9A, and it's activated by contact with negatively charged surfaces. The extrinsic tenase complex involves tissue factor and factor 7A, and it's triggered by tissue injury. Both pathways converge to activate factor 10, which is essential for forming a clot.
So we have an inactive factor 8 and then it becomes 8A, and alongside 9A this comes and becomes the intrinsic tenase.
That's right. Factor 8 gets activated to 8A, and together with 9A, they form the intrinsic tenase complex.
Where 10
this
will
complex
become
then
10A, and 10A will work with 5A, and then that's going to create thrombin.
Exactly. Once factor 10 is activated to 10A, it combines with 5A to form the prothrombinase complex. This complex converts prothrombin into thrombin, which is crucial for forming the fibrin clot.
Awesome.
Glad you're finding it helpful.
Now, what's going on with the coagulation factors for the prothrombin and thrombin group?
So coagulation factors in the prothrombin and thrombin group mainly include factors 2, 7, 9, and 10. These are all vitamin K. Vitamin K is essential because it helps add a carboxyl group to
coagulation factors. I don't understand.
These factors are crucial in the coagulation cascade. Factor 2 is prothrombin, which converts to thrombin. Factors 7, 9, and 10 are involved in activating each other and ultimately forming the fibrin clot.
So 2, 7, 9, 10 prothrombin and thrombin 1, 5, 8. Let me see. Let me try to put the puzzle.
You're doing great. Putting it all together helps solidify your understanding.
I don't know where we found 2, 7, 9, and 10 for the prothrombin.
So factors 2, 7, 9, and 10 are all part of the vitamin K dependent group. They play key roles in different steps of the clotting process, with prothrombin converting to thrombin being a major step.
And why vitamin K dependent equates with the prothrombin group?
Vitamin K dependency means these factors require vitamin K for their synthesis in the liver. This dependency links them to the prothrombin group because it includes prothrombin, factor 2, and other factors essential for clotting.
I see. I'm going to put a pause perhaps to this because I am tired and it's a shame to rush through it. But guys, we will continue this tomorrow, and we are gonna write down here the phrase fresh start. And tomorrow we'll try to get as much as much time as we can of studying.
Absolutely. A fresh start will help you tackle it all more effectively.
Well, I know this was a short episode, but thanks for listening, guys, and I'll see you soon.